Welcome to the Python Deep Learning ICP3. Here, the first the the objective of this ICP is to learn about the embedding layer in Keras, as well as performing the sentimental analysis on IMDb, as well as the Fetch20 newsgroup datasets. The softwares that I have used over here is Python 3, Pandas, and the Keras and TensorFlow libraries. Coming to the first question. The first question is to identify the three mistakes that are given already in the code. The first one is like the input dimensions or the input DIM is not given in the input dimension. This should be equal to the that is over here. The input dimension is not given, and in actual the input dimension should be equal to the number of columns of the trained data set that is obtained after performing the train test split over here. We'll be getting the train uh, will be will be getting this train value. Into this train value, we are using this x train in order to calculate the input dimension. Basically, this will be equal to the number of the columns that are present in the train data set. We are just trying to print the number of columns that are present over here in the x train, and the value of it is going to be 2000, and this 2000 value is going to be the value over here. So this is the first mistake in the code, and the second one is that the neurons in the output layer, that is this one, should be equal to 3, because there are three classes: positive, negative, and unsub in the column label of the dataset, which is the target over here. So target we have already considered as label, which contains three classifications: positive, negative, and unsub, which is why we are just taking it as 3. The third one is that the activation function should be softmax, as it works best for the multi classification, as there are different classifications in the target columns as well. So after doing these three things, I'm just running this code, and I'm able to calculate the loss and accuracy for the same thing after training it to a model, and the loss and accuracy are thereby found to be loss is some loss is this one, and accuracy is 0.5x 5504. And now I'm just plotting the data over here, where ACC represents the accuracy, and loss this represents the loss. So this is the graph over here, which shows the variance of loss and accuracy with the approach. Um, so this is the end of the question 1. The second question is like adding the embedding layer to the model. For this, what we are doing is like first we have to prepare the data. The preparing to prepare the data, what we are doing is like we are preparing the data by tokenizing it and performing the padding after the tokenization. So as you could see here, first we are tokenizing it, then we are applying the padding after the tokenization. Mm, then we are encoding the y value. Uh, we are encoding the target column, that is the y contains the target value, and then split the data. We are splitting the data using the train test split. So after doing this, we are just trying to add the embed layer over here. um, After that, we are using flatten, because flatten is used to get a compatible dense layer as the output of an embedding layer. Um, uh, um, Basically, flatten is used to get a compatible dense layer, since the output from the embedding layer is a two-dimensional output. output. We'll be using flatten after this, and after that it's going to be the normal layers over here. Then we are just trying to calculate the we are just trying to fit the model, and then um, we are doing the same history analysis over here, where we are just trying to plot the accuracy and the loss over here for the history object, new history object, and the accuracy and the loss over here comes this way. So here from here what we could infer from the two graphs is like the performance has been decreased significantly, like from the previous to the now. From this graph to this graph, what we could observe is that the accuracy got decreased, because previously if you see the accuracy line was here over here, where it was increasing. Now the accuracy, if you say, it's just creeping over here, which indicates that there is a decrease in the accuracy, uh, which shows us the performance decreased comparatively. So next, coming to the third question is like we have to do the same analysis using the 20 news data. So here also we are just doing the same thing. We follow the same procedure, except that we are using the 20 news data and we change the output neurons to 20 over here. Previously it was 3 because the target was having 3 things. Now it is 20 because now the 20 news data will have 20 over here. Mm, so after doing this analysis, again we are doing the same thing, that is we are just plotting the loss and accuracy for the new history object that we have obtained, and here we could see that the loss and accuracy goes this way. And coming to the prediction, we are just predicting the over the fourth sample data. So the fourth, we are just taking the actual value, that is y test of 4, to the model dot predicted classes of x test of 4 to identify the predicted value. So the actual value is going to be 4, the predicted value is going to be 6 over here from the analysis. And thank you.